Hello everyone. Thank you for attending our webinar today on Unmasking Your Security Vulnerabilities, Smart ZOS Agent for SIEM. My name is Brian Lampe and I'm the Marketing and Advertising Coordinator at Software Diversified Services. We will have a Q&A session at the end of this presentation. If you have questions at any time during the webinar, please send them to us in your question box. If you still have questions or would like to get in touch with us after this webinar, you can send an email to info@sdsusa.com. You'll find handouts for this presentation on your dashboard under the Handouts tab. You can access and download these at any time during the webcast. Once you leave this webcast, there will be a brief survey that I hope you will take a few minutes to answer. Here's our agenda. After my brief introduction to SDS, Software Diversified Services, Chris Goggins from Type 80 will provide insight into SIEM vulnerabilities. Chris Goggins is an internationally recognized expert on information security with over 20 years experience in network and information security. He has performed network security assessments for some of the world's largest corporations, including all facets of critical infrastructure, with work spanning 22 countries across 4 continents. Mr. Goggins has worked with U.S. federal law enforcement agencies on some of America's most notorious computer crime cases. His work has been referenced in publications such as Time, Newsweek, and Computer World, and televised on networks such as CNN and CNBC. Following Chris, Cullen Vanderross from SDS will discuss Smart ZOS Agent for SIEM and how you can capture and reveal those events. Cullen, a senior systems engineer here at SDS, has over 25 years experience as a customer at a large bank. He has been at SDS for several years now, focused on network software solutions and security solutions. Following Cullen, we will have our Q&A session. SDS, or Software Diversified Services, has been providing mainframe solutions to the market for over 34 years. Our headquarters are located in Minneapolis, Minnesota. SDS has strived to bring software solutions to the marketplace that provide both cost savings while still using elegant and state-of-the-art functionality. We are proud of our world-class support. Over the years, we've developed more solutions for the distributed environment, we've added to our mainframe portfolio, and we've partnered with key subject matter experts for excellent software solutions. Okay, so I'll now hand the webinar over to Chris Goggins from Type 80. Chris?
Hello, everybody. My name is Chris Goggins, and I'm one of the founders of Type 80 Security Software. But as one of my other jobs, I also break into computers. I've been doing this for quite a long time and have seen a whole lot of different things around the world. In 1991, I actually started one of the first companies to ever provide comprehensive penetration testing services. And since then, I've had the opportunity to look at networks in every industry sector in dozens of countries around the world. And what I've seen will probably shock you, but I wanted to talk about some of these experiences and how they relate to enterprise-level security in a way that you may not really be thinking about. So we'll start off with some basic war stories. I was doing some work for a U.S. defense contractor, and we got on site, got set up, and our point of contact was making sure, said, okay, well, this is the area you'll be working in. The Ethernet jacks are over there. So go ahead and set up, and I'll come back in a few minutes and show you where the coffee is. So we got set up, plugged in our computers, started various things, and started some of our scanning software. And the way we run our methodology is we'll basically scan port by port rather than system by system, and that way I can parallelize a whole lot of different attacks at the same time and cover very large enterprises in a short period of time. So we started the scans up, and it's going across various ports looking for services running on hosts across their network, and one of the scans was going against port 23, which is the telnet service. So as that finished, started looking into systems that had telnet access and connecting to them sequentially, one after the other. And one of the first ones that we logged into was just a basic print server. No password required to get access to that. But what we noticed in looking through the configuration file on just this simple printer was that it had been set up with a SNMP, a Simple Network Management Protocol, read-write community string, meaning that you could basically control this device with this community string. It was obvious that this had been set specific to this organization because it had their name in the community string. So we decided, well, let's take a look and see if this community string works on anything else. So we blasted that out against all of the live IP addresses on their network and found out that this community string was also in use on other devices like routers and switches and other pieces of networking gear. Well, one of the things you can do with those read-write community strings is actually pull down configuration files from devices. So we pulled down configuration files from some of their core Cisco equipment and found that accounts had been set up locally to those Cisco devices and were actually protected in the config file with what's called a level 7 hash. This is a reversible hash that allows you to immediately recover the plain text password. And in this case, it was MBHAFNITSOSCAR, which, if you think about it, it's my baloney has a first name. It's OSCAR. So we decided that's obviously something that people think is a good password. So let's see if anybody's using that on the domain controller. So we pulled out all the domain admins from the domain controller and tried that password for each of them, and lo and behold, it worked on one person's account. So now we had access to the domain controller as well as all the routers and switches. Well, we knew this particular organization was also using NetWare, and the Windows domain was tied to the NetWare eDirectory. So we pulled down the passwords out of the Windows domain controller, ran that through password crackers, and ended up finding accounts that also allowed us to log in with supervisor privileges into the NetWare environment. So in total, roughly 15,000 accounts and about 99% of all the systems and network devices were compromised just from one insecure printer. About this time, 15 minutes had passed since we'd been on site. Our point of contact came back by to show us where the coffee was and to make sure that we got set up okay. Needless to say, he was a little disconcerted by the fact that we now had almost everything we needed to compromise this entire organization in such a short period of time from something as inconsequential as a printer. Now, I know this doesn't have anything to do with mainframes, but I want you to be aware that even the most inconsequential thing can lead to major attacks across an organization. For me, when I look at a network, I see it as a series of opportunities, and any one thing can start the first domino falling, where I break into one system and extract that information, then use it to get into another system, and then use it to get into another system, and so on and so on. Every single point of entry, every single attack path, I try to follow to its logical conclusion to see how far one single intrusion can extend across a network. Now, this has dramatic implications on enterprise systems such as mainframes, where by and large, people think of mainframes as islands unto themselves. But there are a lot of cases in most organizations where those hidden attack paths exist, so that even if someone compromises some inconsequential systems, whether it be a forgotten development workstation or some old legacy web application, or even something as ridiculous as a printer, it may have ramifications that lead an attacker to some of the most sensitive information in your organization. To give you a specific example, I was doing some work for a U.S. government agency, and in the course of examining their network, one of the things that we came across was a web server. It was basically a development web server. It was running Cold Fusion, and there were a number of default Cold Fusion scripts that existed on this server whose purpose was to allow you to view web source code. So we took advantage of that and started looking at the actual Cold Fusion source for various web apps that had been installed on this system, knowing that even though this was development, a lot of this is probably the same code that would be running in production. And we noticed in one of the config files that there were database connection strings. And the database connection string was for DB2 connections, and it had embedded in the actual source code a RACF user ID and password that was used to make those DB2 queries. So we took that ID and went back to their mainframe, and lo and behold, that account actually allowed interactive logins and we found out that it had system programmer level access on their ZOS mainframe. And again, breaking into something a lot more important from something that isn't necessarily even given that much thought. The fact that there were live accounts and passwords with high privileges available in development web servers that were accessible through default installation scripts that had been left over from a simple Cold Fusion install. Now, you might think that this is just one example, but this kind of thing happens all the time. We look at another government agency, again, starting off with something completely unrelated, doing scanning across the network, and came across a number of Microsoft SQL Server instances. Well, the default account in Microsoft SQL Server is called SA, and when we find these servers, we try very, very basic passwords for SA. Things like SA, or password, or admin, or blank. And lo and behold, this particular SQL server had an SA account with a weak password. So that allowed us to log in. At that point, since we were in with those high DBA privileges, we were able to use a stored procedure built into Microsoft SQL Server called XP Command Shell, which basically allows you to execute operating system level commands from within the context of the database itself. In this particular instance, the database server was running with system level privileges, meaning it basically had administrative rights on the underlying operating system. So every command we would execute through that stored procedure was run with the highest privileges possible. So at that point, we basically ran a tool through XP Command Shell that would dump the cache credentials and passwords out of this Windows operating system. Now, because there were domain administrators who had logged in recently to this system, their credentials were still cached in the operating system. So we were able to expose these underlying domain administrator accounts just from the SQL server. So now we use that to log into the actual domain controller itself with those domain admin privileges, and found in this particular domain controller there were roughly 50,000 accounts. And because this server hadn't been updated, it still had what's called a landman hash visible in its password file. A landman is an older Windows crypto type that is easily broken with a pre-computed password list called rainbow tables. So we were able to crack the vast majority of those 50,000 accounts almost instantly by running them through rainbow tables. So great, we had complete control over the Windows environment. Well, since this organization also had a mainframe, we noticed in looking through another web application that we were examining, in their online employee directory, it had a number of different fields of information for particular users. So for example, it'd have their full name, it'd have their division, it'd have their building location, it'd have their email address, and in some it actually had their RACF ID. Well, now I had a name that I could map to a RACF ID almost instantly, and since we had every single password, we found that just by trying every single username, every single RACF ID with the corresponding Windows password, a large number of people use the same password on the Windows environment as they did on ZOS. So again, now we've compromised the mainframe as a variety of different users, starting with an attack path that originated with a completely unrelated environment on a server that had absolutely nothing to do with the mainframe. But this lateral movement across the enterprise and this domino effect where breaking into one system gives us access to more and more and more systems. This is the kind of thing that you need to take into consideration when you're preparing your overall security program, because this is the way attackers take advantage of networks. They're not going to just beat their head up against a wall going after the hardest target. They're going to look for the lowest hanging fruit and then try to exploit those trust relationships from that system, or shared accounts from that system, or basically anything that they can glean from the system compromised with the easiest attack path to try to ultimately reach a goal of gaining access to the more important systems. To drive this point home, even the most secure systems on the planet can be compromised in this fashion. We were doing work in a law enforcement environment, and we found a particular Windows workstation that someone, for whatever reason, had set up an IS web server on, and they weren't applying patches to it. So once again, we used that conduit to break in and pull down the local SAM or Windows password file and any cached accounts that may have been present on that system. So with those accounts that we pulled from that compromised workstation, we found some domain accounts and ultimately compromised the Windows primary domain controller through a series of further break-ins from accounts that were gathered from that workstation. Throughout the law enforcement network, there were a number of different classes of systems, obviously, and some of them we found belong to investigators. And these particular investigators had different computer builds. But since we had ultimately compromised the Windows primary domain controller, we now had domain administrator accounts. So we used our domain administrator rights to start examining these investigators' workstations since they appeared to be set up different. And we noticed on one, the system had additional networking devices. You know, we often try to look for machines with multiple network adapters to see if someone has set up some sort of bridge to a more protected network, whether it's, you know, acting as sort of a firewall or a mini router, or just having two separate interfaces that are dealt with independent of one another. But on this one, we noticed that it had an SNA adapter, which seemed odd because they had absolutely no mainframe or other IBM type equipment installed in this location. So this was worth a closer look. We also noticed that this particular system had already installed remote control software. It was using VNC. Now VNC stores its password locally. On Unix systems, it's stored in a little config file, and in Windows systems, it's stored in the registry. So since this was a Windows system and we had domain administrator rights, we were able to connect to that system's registry, extract out that VNC password, and then could log in over VNC to the actual workstation, and now we had full remote control GUI style access onto this workstation, so we could see what that investigator would see when he or she used their workstation. So once we logged in with that VNC password, we noticed right on the desktop there was an icon that said MILES. MILES stands for the Maryland Integrated Law Enforcement System. So by clicking on that, we started noticing all of the different things that could be accessed through MILES. And basically, this particular machine over its SNA adapter went to a terminal server and went out from there to various different law enforcement systems. So at that point, with the simple addition of a keystroke capture program, we would have access to the FBI's National Crime Information Computer. Now, this particular configuration flew in the face of all of the security guidelines that the FBI provides to local law enforcement about how to access NCIC. You are never to do it on a network system. It's supposed to be on a standalone system. It's supposed to be something that's directly connected to that terminal server. But in this particular environment, I guess to try to save money or to not have to buy another system, they decided to make dual use of this particular investigator's workstation. Now, needless to say, after we found this, the FBI was not too pleased with this particular law enforcement agency, and they had to make changes. But again, going from a workstation with an unpatched web server to ultimately find paths to break into the FBI, that kind of thing's just, that should be unfathomable. But those kinds of attack paths and those kinds of gaining access to the more critical systems are what happens all the time. Now, when we think about the most common issues that I see across networks, there are really, 4 basic things. First one's patch management. And nearly every organization I've ever examined has been woefully behind in their patches. And this could be as a result of not having automated software to handle operating system level patches, or especially third-party patches, whether it's just additional enterprise software that's installed, or even things like plugins to browsers and other applications. Everybody's behind. I don't care if it's a classified military network or a .com startup. Almost nobody in the world is 100% up to date on all of their patches. And because of that, each one of those presents an opportunity to an attacker. Another of the most common issues is misconfigured services. A lot of times where people will just set up an application and not take the time to lock it down from a security perspective. And this will lead to things like file shares that were open to anonymous mounting, or making things visible to everyone on the local area network, which may or may not expose sensitive data over those insecure file shares. We'll also see poor access control, where people have access to directories or files that they shouldn't. And most often than not, a lot of this is due to just default settings. People will install software, make sure that it's running, and then move on, leaving everything as it came in its default state, which again presents a major attack path in a lot of cases for an attacker. Another issue that we run across all the time is poor coding practices. This leads to vulnerable web applications, a lot of things that end up being internet-facing, that are vulnerable to command injection or local file inclusion or SQL injection, or any of the other myriad of web application vulnerabilities that are prevalent across the internet today. We also see problems in desktop applications where things will be hard-coded into these thick clients, where usernames and passwords can be easily extracted with something as simple as a debugger. And of course, all this falls true for mobile apps as well. But the number one mechanism that's still used by attackers to gain host-level access is still poor passwords. It might seem ridiculous. It's 2016, and people are still setting an administrator's password to password. It's true of every organization I've ever been to, in every country, in every industry sector. So why am I going to scratch my head and try to find what's called a zero-day exploit, some heretofore unknown way of breaking into some strange service, when I first am going to try basic usernames and passwords, and a large percentage of the time that's going to get me in? Well, you may think, that's not true of the mainframe. There's all sorts of restrictions and password complexity rules that can be placed in the mainframe environment. But I can tell you, in recent engagements, even those mainframes have been found with poor passwords. At a Japanese bank, we logged in with IBM user, password IBM user. At a U.S. government agency, operator, operator. At a credit bureau, again, operator, operator. And at a large department store chain, IBM user with a password of IBM user. This is simple stuff, but it still gets overlooked. And when there's default accounts or things with obvious passwords, it's going to lead to people gaining access to things that they shouldn't have access to. And once they've gained access to it, then what? So one thing I get asked often is, do hackers even care about mainframes? I mean, so much of what we hear about people breaking into has to do with more distributed systems, people breaking into Linux boxes through misconfigured Apache, or people breaking into Windows systems because of buffer overflow attacks and what have you. Well, when it comes down to it, your average hackers, they care about anything they can break into, and if they can break into something new and novel that they haven't seen before, so much better. By and large, most of the attacks over the internet are opportunistic. People are just constantly scanning, looking for things A new vulnerability will come out for some particular service, and hackers will scour the entire internet looking for instances of that service, and then breaking into it and then seeing what's there. Now, when you get into actual criminal hackers or criminals that use hacking techniques, people who are more interested in stealing something, whether it's financial data or intellectual property, not just looking for something to do, but actually with a financial motive in mind, they're going to care about breaking into whatever stores the most important data. And in a lot of organizations, that important data is going to reside in one spot, and that's on the mainframe. And I've actually noticed there seems to be a really renewed interest in the mainframe lately. Just earlier this month, Reddit hosted an Ask Me Anything session with a panel of Z-Series security experts. That struck me as really interesting because that's not the typical kind of thing that Reddit's AMAs are. You expect to see Kanye West or something doing an Ask Me Anything, not a panel of Z-Series security experts. And that was just a couple of weeks ago. And then there's a website that I've been seeing a lot of really interesting articles on, and I encourage you to take a look at it. It's bigindiansmalls.com. And this particular person's actually been creating modules for a common attack tool called Metasploit. Actually been creating Metasploit modules specifically for mainframe-related attacks. So if there are now going to be modules that are available and incorporated into one of the most common attack frameworks, you bet that people are going to be focusing a lot more attention on the mainframe, because now people are making it easier and easier to do things, whether it's to escalate privileges or extract data. If there's a module for it, now you don't actually have to have all of the knowledge that you would normally need, because you have a tool that's going to do it for you. So this is all fairly recent developments. So definitely people are going to take a closer look at the mainframe, even more so than they have in the past. So what this all boils down to is, from my perspective as a consultant, it's not about perfect security. It's about due diligence. We're probably going to get into your network. We're probably going to find flaws. But, there was a quote that came out some time ago from the Computer Security Institute, and it's pretty apt. Given the inevitability of computer losses, you're going to be judged not by whether you were the victim of an attack, but how well you planned for it. How good is your enterprise monitoring? How much have you locked things down? Are you going to be able to notice this traffic from one system to another? Are you going to be able to notice these internal probing attacks if someone's able to get a foothold? It's rare that someone can't find a way into an organization, and once they're in, more often than not, organizations are woefully ill-equipped to watch for that kind of hacker activity on their internal networks. And this is an important thing to take away from this. So, when we created Type 80, a lot of this came from my experience doing security vulnerability assessments at major networks. And from my experience working with the more traditional intrusion detection systems. And working with some of my partners at Type 80, I asked them at the time, like, well, how is security handled on the mainframe? How do people get notified? How are alerts distributed? And the answer was always, well, there's various security facilities that track unauthorized activity. I'm like, well, what about an authorized user doing unauthorized things? Because I have all these different ways to get accounts. How are you going to know that that's me doing something? What if I steal a privileged account and I start looking at things? Is there any way to track that? The answer was, well, kind of, but not really. Most people aren't doing that. I'm like, well, that seems kind of ridiculous. I'd want to know, if I have something that's a file that's, I don't know, tracking electronic fund transfers over $10,000, I'd want to know anytime someone accessed that. Or if I anybody accesses system config files or password files or something along those lines, anything that's important, even if they have access to it, I want to know if they've touched it, just so I can verify. Going back to that old axiom of trust but verify. Similarly, I'm like, okay, well, let's just forget about that for a second. Well, how do the mainframe people alert the people in the Security Operations Center that there's malicious activity going on? Like, well, in general, batch processes will get run, and an audit trail will get generated, and this exception log will be made available. And I'm like, well, that doesn't do me any good. Well, how often does that happen? Like, well, usually it happens, in maintenance windows in the late evening, and alerts will generally be distributed 24 hours later. I'm like, well, that's unacceptable. Coming from a traditional model with intrusion detection, I want to know instantly. If someone's doing something to my system, I want to get an alert. I want to be paged. I want it to show up in my enterprise log management. I want some sort of notification right away. And that just really didn't exist. So when we created Type 80, it was to try to not only make people aware of what's going on, not only by unauthorized attempts, but actually authorize users doing what may be unauthorized things, and to make that information available to the people who need it. From my perspective, part of real due diligence is maintaining that situational awareness of your environment. If you don't know or have the ability to monitor stuff going on in your own network, so many organizations only pay attention to things at their perimeters, but knowing what's going on in all of your various systems and consolidating all that data where you can actually run programs to look for alerts that are scattered across disparate systems, so you can see, hey, someone's trying to break into all of these different systems and it seems to be coming from the same workstation. Be able to concatenate all that information so you can really find out the source of the problem. That's good situational awareness. And if a critical component of your organization, like your mainframe, where so much important data is being stored, if that's not included in your enterprise security monitoring, then how could you possibly have good situational awareness? Oh yeah, we know we get all of our event logs and sys logs from Unix systems and a few things from different applications that get dumped into our SIEM, but the mainframe, which handles all of our financial transactions, we don't get any information from that. Well, that doesn't seem like a good idea. So that's where Type 80 comes into play. And our SMART program really helps organizations bridge those gaps in their enterprise monitoring by delivering any mainframe-related security data to those who need it and doing it in real time. We want to make sure that people in the SOC and people who use enterprise SIEMs have all the information they need to really make sure they're making the right decisions about how to react to situations on their network.
Thank you, Chris, for that inside scoop and also the very interesting war stories. It is amazing how the simple things can sometimes be the access point for unauthorized users to gain access to customers' networks and their systems. So for the next few minutes, I plan to provide you with technical detail on the SMART product. SMART, for those of you that are not familiar with the acronym, it stands for Security Monitor Alert Real Time. So Security Information and Event Management, or SIEM, is an approach to security management that seeks to provide an holistic view of organizations' information technology, or your IT security. SIEM combines SIM, so that is Security Information Management, and also SIEM, which is Security Event Management, and these functions all into one security management system. The underlying principle of a SIEM system is that the relevant data about an enterprise security is produced in multiple locations. They can come from routers, switches, Windows platforms, Linux, and also ZeOS. And being able to look at all of this data from a single point of view makes it easier to spot trends and also see patterns that are not normal. SIEM systems collect logs and other security related documentation for analysis. So SIEM is the core of defense in an in-depth strategy. The attackers leave behind a trace, as Chris mentioned. Those inevitably are contained in the logs. One of the interesting sayings that I really like is, given the inevitability of a computer loss, you will not be judged not by whether you were the victim of an attack, but for how well you plan for it. So you'll know, for example, when the event occurred, why it happened, and what happened if you are incorporating ZOS as part of your SIEM strategy. Let's discuss some of the features of the Smart product. So the syslog agent and the Smart agent are really powerful tools. The Smart agent works along with your mainframe system authorization facility, so your SAF product. We can work alongside RACF, ACF2, and Top Secret. It uses intelligent data mining from several system sources, so messages that are written to the console and SMF events, including DB2 auditing. And the big thing is here, it is all in real time. And this is to provide an additional level of mainframe security. It monitors internal activity by looking for patterns of abuse and defends against particularly the denial of service attacks. Smart supports all of the operating systems and Unix system service log events at an individual LPAR level. The syslog agent focuses on console messages only in real time, but does not process SMF. The Smart agent, however, includes the syslog functionality, and both of these share the same code and run as a starter task on your LPAR. Smart mainframe agents, they process in different LPARs, and they are not required to have the same mainframe SAF product, but can work with all or combinations of existing SAF products. So for example, if you have a KEK that's maybe running ACF2 and another KEK running RACF, we don't really mind. We can work with either one of those. That is no problem at all to the Smart product. The mainframe agent monitors activity within the LPAR, and it examines event records, policies, and escalation factors and issues. And then alerts are sent out through UDP, and this is something that you can configure in the product, what UDP port should be used and where it should be delivered to your enterprise SIEM manager. Here are a few features of the Smart product. It has a TSO rule generator. So this is an ISPF TSO program that allows users to perform policy maintenance when the Smart task is not running. A future release, we are considering maybe adding this dynamic rule generation where the starter task can be up. Then we also have the batch rule generator. So this is a batch mode program to generate the various Smart rules. This option may be used with or without the TSO rule generator, and it depends on your preference. Bear in mind, it must be run on the LPAR where the TSO rule generator is run and which owns the configuration files. This could save you a considerable amount of time depending on how you enter the initial data. So this is something to consider. If you have a bunch of rules, just use the batch rule generator to get them active in the product. Then we have the batch feed of SMF records. I think this is a really cool feature. You can submit the batch job that reads some archive SMF records, and then you can write them either to in real time to the Smart product or to an output data set. So perhaps you have some archived SMF records, maybe from a year or two ago. You need to figure out what occurred on them. Use the batch feed of SMF records to get visibility on what transpired on those SMF records or those events. And then lastly, the alerts, they delivered from the mainframe agent using UDP to your threat management system or your IDS, and this is in the standard Unix syslog format. What problems does the Smart product solve? Let's talk a little bit about log consolidation. All of you know that the ZOS SMF logs may be over 32K in length, and the ZOS SMF logs are in binary format. I'm sure you've worked with them. This is sys1.man files. Also, console messages and write to operator messages scroll off terminals faster than anyone can read. It's almost an impossible task to try and keep up with the messages on the system console. Analyzing logs can sometimes prove to be a difficult task and not the most effective way to get to the cause or the root of the problem. And also console logs we find are they're very seldom reviewed for security, compliance, and auditing. It improves the efficacy of RACF, ACF2 and top secret, and SMF and console messages. It is a true real-time monitor and delivers mainframe alerts immediately to your SIEM event manager. When I was testing the product, I installed it on my sandbox and I installed a syslog monitor on my laptop, so I didn't have a full-blown SIEM on my laptop. I went into sys1.palmlab. I knew I didn't have access to palmlab. I tried to update the member, and immediately as I saw the ICH408i message pop up on my screen, the message appeared on my laptop in my syslog monitor. So it truly does send events in real time. We use state-of-the-art capture methods to capture the alerts, which I spoke about, the intelligent data mining from several different sources. And also it integrates quite easily with your existing enterprise security monitor. So it doesn't really matter what you're using. You might be using Splunk or HP ArcSight. We don't really care. The product integrates with any one of those. Also, we have some APIs that you can use. Customers can use this to produce customized events. That is something that I will talk about later in the presentation. Smart also enables the extension of mainframe console messages and write to operators to be routed to the external log retention servers. The easy integration with centralized security activities within the enterprise SIEM, and it is also a cost-effective solution to monitor IBM ZOS as part of an enterprise-wide security program. So where do we get our data from? We get data from SMF records and also DB2 audit SMF records. So you may be familiar with the SMF 100 and 102 records. And we also get information, or we collect data from write to operator messages. The smart SMF exits, they capture events in real time. So each SMF record is passed to the installation exit, either the IEF U83, IFU 84 or IFU 85 before it is written to the SMF dataset. Also, write to operator messages for an LPAR enter the smart supplied operating system interface, and this system interface is automatically and dynamically installed at startup time. The product runs as a starter task on all of the LPARs that you want security events reported on. We use the industry standard UDP, so Smart can send events to multiple destinations. Perhaps in your environment you have more than one enterprise SIEM for resilience purposes. Then you can configure the product to send to both of those enterprise SIEMs. That is no problem at all. You can also write to DASD if your preference is not to send to an enterprise SIEM and you only want to log the data to a file on DASD. That is something that you can do. And also user SMF records. And as I mentioned previously, you can configure to write security messages on the syslog and some monitor of your choice. This is that ISPF interface I spoke about. This is that series of ISPF panels that allows you to define what is monitored, and the rules you set up, they are configured and stored in vSAM files. Then we have a few APIs that can be exploited. There's the batch API and the CICS API. The batch API we found is not that widely exploited in customer environments, but it's certainly available there if you want to use it. An example might be you want to monitor any batch activity where there's a deposit over a certain amount of money. That could be one way for you to exploit the batch API. And then also there is the CICS API, and as you can see, there's some of the specifics about the CICS API. So this diagram illustrates how you can gather data from the different distributed range of systems, including ZOS, and send it to a centralized location. We've been finding more and more ZOS was probably excluded from your SIEM strategy or from customer SIEM strategy, but lately it's getting a lot of visibility, and ZOS is now included in that SIM strategy. In this example, I have an agent running on a Alpha in Chicago, one in New York, and one in Los Angeles, and they're all sending events through to my SIM, the local SIM. And as you can see, one is running ACF2, in New York we're running RACF, and the one in Los Angeles is running top secret. Okay, I want to talk a little bit about the smart product and how you can implement the different levels of filtering. We know that to process the vast amount of data coming from SMF and write to operators and not filtering out irrelevant events, that would probably be like trying to drink from a fire hose. One thing to bear in mind is that you do not want to you want to make sure that all the events you report on is of great importance to you and your company. So let me show you what Smart can report on and how you and your team do go through or make sure that you report on the correct ZOS events. So within the MVS facility, the SMF exits accept only the requested SMF types. So for security types, accept only requested events, and also the subsystem interface accepts only requested write to operator messages. And bear in mind that both single and multi-line messages are supported. Within the smart address space, there are rules for user, files, devices, and also messages. It is also possible to set threshold triggers, so if that's something that you want to use. And this is very nice because it allows you to set appropriate thresholds for some of the events that you want to monitor. So there's different filtering of SMF events, and this is level 1. The smart SMF exits pass only to the starter task the 14 SMF types that are requested, and I'm sure you're pretty familiar with them. The subsystem interface filters out all of the write to operator or with reply write to operator messages and their responses, and also some of the operator commands. These never get as far as the rules evaluation process. So an example might be a CICS. CICS could issue a write to operator, perhaps telling the operator that a major component cannot be initialized. The informational messages that precede the write to operator are standard write to operators that Smart processes, but the write to operator to go or cancel the operator's reply, that is filtered out. So below are some of the SMF events or the record types that can be presented to Smart for further processing. So 14, SMF 15, 17, 18, which is the rename of a dataset, 30. So that's when a batch job terminates or a starter task goes up and down. Termination of a TSO event. Then you have security events, which are SMF 80, SMF 102, which is the DB2 ordered classes, 109, these are created by the syslog daemon. Those are TCP/IP server applications and components that use syslog D to write log messages and trace messages. 119, I'm pretty familiar with that because we have a lot of networking products in the STS portfolio, and there's a lot of good information contained in some of those SMF 119 records. Then we have level 2 filtering, the smart SMF exit for the SAF types, so whether it's RACF, ACF2, and top secret. So they only pass the security events that are requested by the monitor keyword. So that's something that you can set up. You can say, for example, monitor events 1 to 7 and 27, and only those will then be passed to the smart product. And here you can see, for example, this is a RACF sample, but the same applies for top secret and ACF2. So there you can see job initiation, and this is just an example just to give you a feel for what you can monitor on the product, or what you may want to code up and what you want to monitor. So here, for example, these are RACF. Here I've chosen to monitor events 8 to 25, 59, 66, and 87, and that's all within the SMF 80 record. There's some powerful commands here. I'm sure there's some security folks on this webinar that are very familiar with these commands, and there you can see some of the other ones that you maybe want to monitor. The delete user, that's a command to delete the user from RACF. You may want to be made aware of that. The ralter command is used to alter the profile for one or more resources belonging to a class, so that could be a pretty important one. Here's some that I chose to include for Unix. The change audit, that changes the audit attributes of the specified files or directories, so that could be pretty important. The chown command, that's one that I've used a few times. That's a pretty powerful command. Again, that uses you use the chown command to change the ownership and group of file directories and links. So that could be one that you perhaps want to monitor. Okay, so I'm kind of heading toward the last piece of my presentation. I have a few samples here that I'd like to show you, and I must tell you this is a vendor environment, so it's not the busiest environment you're ever going to see, but I just like to give you a few examples of some of the tests that I ran here in my environment, and this was run quite a long time ago when I was testing the product. Here, for example, these were messages that were sent from the smart agent on my sandbox to my syslog monitor, and this particular one was a console message where insufficient access was. I tried to update the TCP/IP profile dataset, and there you can see the ICH 408I message. So this is just a quick example of how you can send these events to your SIM. The right to operator login failure, that could be one that you maybe want to monitor. Also, when a user ID is revoked, I remember when I worked for the bank I worked at, we used to have these maintenance user IDs, and every time the user ID was used and you logged off automatically, it got revoked. So that's one way that they used to track. You had to get specific change control in order to use some of those maintenance user IDs. Perhaps you want to monitor when the starter tasks come down or when they initialize the SMF 30 and 32. Those are going to report on those. SMF 17, deletion of datasets. Perhaps there's some critical files. In this case, for illustration purposes, I used a payroll file. That could be something that you want to monitor. And then some of those FTP logons. Are these all authorized logons? Perhaps you need to go back a year or two to figure out why this person logged on in the middle of the night, and then you're going to have evidence to see, track this problem, go back and see exactly what transpired. The opening of and closing of datasets, so those are SMF 14, 15, and 62. Those are certainly ones that you can monitor. And also the right to operator. So here's the TSO FTP logon password failure. Those may be ones that you want to monitor. So these are right to operator messages that you may want to monitor. Lastly, the SMF 119, as I told you, there's a wealth of information in those. Maybe when FTP and FTP complete, you want to be made aware of it. That is something that you can monitor. This is my syslog monitor I use just to give an example of the messages. I customized mine. Bear in mind, this is not a fully blown SIM enterprise manager. This is just a syslog monitor. So thank you everyone for your time. I'm now going to hand it back to wrap up the session.